Welcome, this is 6.4 absolute value equations, and we're going to actually gear this more towards inequalities. Even absolute value equations is a little bit abstract, it's a little bit out there, and as long as if you're checking your answers, hopefully you're agreeing that, well, the solutions are right, even if it seems a little bit like a magical process that we're doing here. So again, we're looking at absolute value. Those are the absolute value symbols, equations, equal signs. What we're going to look at now is absolute value inequalities. So here is one. And again, I like to think of absolute value as distance. So my solution are the distances that are greater than 4, in this case from 0. So where could my distances be greater than 4 from 0? Well, it could be these distances. Notice I made it an open dot because that's a greater than symbol. And I can do that split that we've been doing, that magical algebraic process here, folks. If I do the algebra here, what Mr. P told me was to drop once the absolute value sign is isolated on one side of the equation, or inequality in this case, drop it and just copy it down. Boom. Hey, isn't that what I just graphed? Yeah. Wow, but with these absolute values, usually there's a second answer, right? Well, let's do the same thing essentially. Now we're going to drop the absolute value sign and make this value opposite. It's kind of like I took the opposite of everything, but that essentially. Now this I need to make opposite. So when I take the opposite of this number, I need to take the opposite of that sign. So my second answer is x is less than -4. Hey, and doesn't that make sense? Aren't these distances greater than 4 steps away from 0? Here's how I like to think about this situation. My distance from something, from lacrosse, is greater than some number. So let's pretend our distance has to be greater than 10 miles from lacrosse. So you would need to be, if you think about a map, you have to be at least 10 miles north of here, which is like Holman. You could be 10 miles south of here, which is like Stoddard. You could be 10 miles east of here, which is, I don't know, like Bangor. You could be 10 miles west of here, which is like La Crescent. If you need to be at least 10 miles away from La Crosse, you need to be to those cities or farther. It would actually create, if here's La Crosse, it would be a circle around La Crosse with some radius of 10 miles, and it would be greater than that. Anything outside of there, get away, get away. Maybe the stinky brewery, really mess something up and the stink down there spread everywhere. So we got to be at least 10 miles away so we don't have to smell it. Or else maybe we want to stay close to home. Here the distance is less than some number. We want to be close. And in this case, because there's nothing else inside of this, it's with respect to 0. But when we start multiplying or dividing or adding and subtracting things to the x within the absolute value sign, it complicates things a little bit. So on the number line, what are numbers that are less than 7 steps from 0? Well, 7 is too far. But anything just inside of that, 6.99, is less than 7 steps, less than 7 full steps to 0. So we can do this split thing again. I'm going to do the algebra behind it now. So x is less than 7. I've dropped the absolute value signs. That's one of my solutions. Let's drop the absolute value signs now. But then I need to make this a -7. And when I flip this to the opposite, I have to flip this the opposite direction. So it's going to go this way now. So the second solution portion to this absolute value inequality problem is, according to my math here, which is correct, x is greater than -7. So -7, x is greater than that. If you plug in any of these numbers here, folks, this is really abstract. This is kind of confusing and complicated, but if you take your time and check some answers, it should make sense. If I plug in 0 here, because 0 is part of my solution set here on this problem, is the absolute value of 0, which is 0, less than 7? Yes. 10 is not a solution here, according to my graph. Or my statements right here. Let's plug in 10 is the absolute value of 10 is 10. Is 10 less than 7? No, it's not. So you can use your number line in these statements to trust your answer a little bit better. Let's go back and trust or check our answers up here. Let's try 0. Is 0, the absolute value of 0, is that greater than 4? No, 0 is not greater than 4. You could always check your numbers right here where the points are, whether they're open or closed, and make sure that if you plug that point in, that number in here, you should get the two numbers are equal. And that happens here. Let's try a number to the right of 4. So let's try 5. The absolute value of 5 is 5. Is 5 greater than 4? Yes. Let's try a number shaded here, which would be like -5 would be the next one. Let's plug in -5. Is -5, the absolute value of that is +5. Is +5 greater than 4? Yes. So checking your answers, taking your time, not racing through things. If you're struggling a little bit with why we're doing what we're doing, is this actually going to give me the right answer? That's a good thing to do. Alrighty, so let's try some here. So those were some equations here on your notes. Remember, one of the first steps is to isolate the absolute value term. So this absolute value symbol here is not isolated. There's this imposter outside there, that +2. We don't worry about stuff inside before we do the split, but we can't split until we undo adding 2 by subtracting 2. So we get the absolute value of x minus 3 is less than or equal to 15. Now we do our split. These two steps are essentially doing the split. So we rewrite the expression without the absolute value sign. So x minus 3 is less than or equal to 15. The second part of the split is writing the expression again, but switching the inequality sign and changing the sign of the constant. So, in other words, we go x minus 3, that expression stays the same. This 15, like we did with the equations, absolute value equation, switches to -15. And the greater than or equal to symbol switches to a, you'd read this left to right. So less than or equal to symbol changes to greater than or equal to symbol. The Pac-Man direction flipped. By the way, here I'm thinking my distance is less than or equal to some number. So here's where we want to stay close to home. This is going to be an AND type statement. So we add 3, add 3, add 3, add 3. The smaller number goes on the left, so -12 is over there, 18 is on the right. X has to be greater than or equal to -12, that's that way. X has to be less than or equal to 18, close dot, and that's that way. The distance is less than some number. Have to stay close to home. You know what? I'm going to actually switch this one. Go ahead and do that in your notes. Let's make that greater than or equal to. So let's look at our process. is the absolute value sign isolated? Is there anything outside of it on that side of the inequality symbol? Nope. So now we can go ahead and do our split. So just rewrite this without the absolute value sign. X minus 5 is greater than or equal to 19. Now for the second one, x minus 5 is less than or equal to negative 19. Uh-oh, you know what? Yeah, we'll be all right. We'll go for it. We'll see what happens. So there we go. So let's add 4, add 5, add 5. Add 5, add 5. So we get x is greater than or equal to 14. And x is less than or equal to, that's 24. That's negative 14. Distracted, making sure my little switcheroo is going to work out the way I hope it will. So here our distance is greater than something. It's like trying to get away from lacrosse if it's stinky. So we need to be on a number line. We need to get out of here. So we need to be at 24 or greater, or at negative 14 and less. Boom. So distance is less than some number makes an and type statement where your numbers are sandwiched between the two values. And then when our distance is greater than or equal to something, we're going to get an or type situation.